Have you heard of the sun's mysterious corona? It's a fascinating puzzle. Imagine it's a cold night, and you're having a nice bonfire with your friends. When you're close to the bonfire, you feel warm. In fact, the closer you get to the burning wood, the hotter you feel. If you go away from it, you start feeling cold again. Simple thermodynamics, right? But it turns out this doesn't apply to the sun. The temperature of the sun's core, where nuclear fusion takes place, is nearly 15 million degrees Celsius. As we move away from the core, the temperature decreases to around 5,500 degrees Celsius at the surface. So we expect a similar trend as we move more and more away from the surface. But that's not the case. Instead, the temperature mysteriously starts rising out from the sun's surface. That's the solar corona mystery. Corona is the outermost layer of the sun's atmosphere that is visible during a total solar eclipse. The story of the coronal heating problem began with a green spectral line observed during an 1869 total solar eclipse. Looking at the spectral line, scientists identified the composition of the element emitting that light. But the green line observed in 1869 didn't correspond to any known elements on Earth. So scientists thought perhaps they discovered a new chemical element, and they called it coronium. Not until 70 years later did a Swedish physicist discover that the element responsible for the emission is iron, superheated to the point that it is ionized 13 times. And therein lies the problem. Scientists calculated that such high ionization levels would require coronal temperatures around 1.2 million degrees Celsius, nearly 200 times hotter than the surface. How can that be possible? How can heat flow from the colder surface of the sun to the hotter corona? It's against the laws of thermodynamics. Scientists and engineers have done a great deal of work to understand this behavior. They've developed powerful models and instruments and launched spacecraft that watch the sun around the clock. But even the most complex models and high-resolution observations can only partially explain coronal heating, and some theories contradict each other. But we still have hope. Scientists realized they could never fully solve the coronal heating problem until they sent a probe to measure the corona itself. The newly sent spacecraft like Parker Solar Probe is helping scientists to understand the behavior of corona by taking measurements at every single point during its journey around the sun. From the Earth, the sun looks very different from what it is in reality. On Earth, we have the privilege to enjoy the beautiful and calm sunsets, but up close, the sun is the most dynamic place in the solar system. It is a mysterious place where magnetic fields twist up to thousands of kilometers, releasing tons of billions of watts of energy. The dark spots big enough to engulf the Earth, and the violent eruptions blasted into space. Yet, despite being the most well-studied star in the universe, there are still many mysteries about how it works. Another mystery is the solar cycle. Every 11 years, something strange happens in the sun. The entire sun is nothing but a huge magnet with north and south poles. However, it's not that simple. Every 11 years, the entire magnetic field of the sun flips from north to south. Another 11 years, and the poles flip back again. This cycle of 22 years is known as the solar cycle. But how was it discovered? This strange activity was first found in 1844 by Samuel Schwabe. He noted that the number of sunspots increases and decreases over 11 years. Furthermore, the number of sunspots is low at the solar minimum, while they are relatively high at the solar maximum. Surely, something must be going on inside the sun that is causing a change in activity on its surface. Although we know it's linked with the magnetic pole flip, we don't understand why it happens. In 2020, we entered the 25th solar cycle. Over the next 11 years, as the sun wakes up from its slumber, it will get stormy. This could impact our space satellites and, most importantly, the Artemis mission, the first human crewed mission to the moon in decades. The third solar puzzle on the list is the nature of the sunquakes. Do you know that there are ripples in the sun, just like ripples in a pond? Using a technique based on wave optics known as helioseismic holography, scientists found that the source of these mysterious waves seemed to be thousands of kilometers deep below, in the hot interior of the star. Understanding how the interior of the sun behaves can be a crucial component to unravel the origin of the magnetic field of the sun. The question is, what could be causing this? Scientists dig deeper with the two most common hypothetical energy sources for this seismic activity: convective instability and magnetic free energy. They both are ruled out as they fail to describe the observations, and the mystery remains unsolved. Another solar mystery that directly affects us is predicting solar storms or space weather. The answer to this can lead to many questions like, how is it connected to the sun? Can it be harmful? Do we have any warnings of bad space weather? Let's look at them one by one. Activity on the sun's surface creates a type of weather in space called space weather. It can affect Earth and the rest of the solar system. Massive solar storms like coronal mass ejections can even damage satellites and cause electrical blackouts on Earth. So what about warnings? Solar physicists are constantly trying to predict these massive storms by studying the environment near the Earth and the Sun with the help of real-time observations. But they still lack accuracy. Last but not least, the solar dynamo theory. One of the central problems in solar physics is understanding the origin of the sun's magnetic field. From sunspots to coronal heating, from solar flares to coronal mass ejections, all these diverse phenomena have magnetic fields as their ultimate cause. It is, therefore, no wonder that one of the most fundamental questions of solar physics is, how is the magnetic field of the sun generated? There is no direct information on the magnetic field underneath the sun's surface. So far, the only theory which has been most successful is the solar dynamo theory. The theory attempts to explain the magnetic fields generated by complicated, nonlinear interactions between plasma and magnetic fields by assuming that there was already a seed field present when the sun was born. It uses the principle of hydrostatics and Maxwell equations together called magnetohydrodynamic equations, MHD. While we now seem to have a broad understanding of how the solar dynamo works, many pieces of the jigsaw puzzle are still missing. The sun is among hundreds of billions of stars present in our galaxy. Thus, decoding the mysteries of the sun is a fundamental task to understand the stars that are gravitationally bound together to form galaxies. If you're interested in studying astrophysics at home, make sure to check out our Basics of Astrophysics series, the link to which is given in the description. This series explains everything at the most fundamental level, from the EM spectrum to telescopes, and from the birth of stars to the formation of black holes and galaxies.